What's up, everybody? It's Jeremy from the Renegade Coder, and today I want to talk a little bit about inverting dictionaries in Python. And if that topic sounds familiar, it's because I've actually written an article about it, and we have that here. And it's basically just titled How to Invert a Dictionary in Python, Comprehensions, defaultdict, and more. In particular, though, I've had this article open because I want to talk about the problem introduction, which gives us a good place to start. So basically, we're going to have a dictionary, and this dictionary is going to look like this. And this dictionary is just going to have strings mapped to strings. So in this case, I actually have mapped My Hero Academia characters to their quirks. So in this case, Deku's mapped to One for All, Bakugo is mapped to Explosion, those sort of things. And to get started, why don't we go ahead and copy this right into our editor. Okay, good there. So that's copied in. And now, if you know anything about dictionaries, we have a lot of options here. So I can empty the dictionary, I can copy the dictionary, I can get some items from the dictionary. And so you might be familiar with the sort of array syntax as well. So I might type in a key, Izuku Midoriya, and that should return one for all. And then if we, pass in a key that doesn't exist, we should get a key error saying that that doesn't exist. And you may also be familiar with this other syntax that looks sort of like this. And it lets you pass in a key. So I'm going to pass a good key again. And then that alone will just return the value. If I send a bad key, that's going to return nothing. And the reason that that's different is that normally if we have this array syntax from before, we're going to basically brute force ask, hey, give me that value for this key. And then, of course, we get a key error. But in this case, there's actually a bit of a wrapper on that original syntax that lets you specify what you want it to return. So in this case, maybe I want this to return none, and so it doesn't return anything. Or maybe I want this to return some generic power. So in this case, one for all. Even if I give the wrong key, so no matter what, even if I type in Bakugo, which is part of his name, we still get one for all. So that's sort of an introduction to how to actually interact with the dictionary. But we want to do something more interesting. Instead of mapping characters to their powers, we want to map their powers to the characters. Ultimately, we want the dictionary to look something like this. Now, you'll notice something weird. The My Inverted Dict right now has only 3 items in it as opposed to the 4 that we had previously, right? So the issue here is that we originally had a 1-to-1 mapping, and now we want to map 1 to all the characters because while the character names are unique, their powers may not necessarily be unique. And so an obvious example is Deku and All Might both have one for all. So if we create a dictionary that has a list of all the powers, in this case, one for all, it should include all of the characters that have that power. So Midoriya, All Might, that sort of thing. As it turns out, there are actually quite a few ways to invert a dictionary. One of the first ones takes advantage of this items command. And so when you call mydict.items, you actually get a list of all the mappings from the dictionary as a list of tuples. So we'll take advantage of this and the map command. And if you're familiar with the map command, it takes an iterable, which would be like a list, and it allows you to apply a function to each item in that list. So in this case, we're going to apply the reversed function, which the reverse function is going to reverse, as you could imagine, all of these tuples in our list. So we'll go ahead and pass mydict dot items, and that's going to return some map object, and we can actually convert that map object back into a dictionary. And so this is sort of what our first solution looks like, where we have kind of just blindly applied the reverse function to each of these tuples. So we reverse this tuple, you get one for all on the left here and Midori on the right. Same goes for all the rest of the tuples. And as you go through, you will find out that we don't get the result that we want. One for all gets mapped to All Might. Explosion gets mapped to Bakugo. So two of these keys and these key pair mappings are actually correct. But the one that's wrong is this one. And the reason why is we actually, when we apply this dict, we only really map 1-to-1. So this gets reversed, this gets reversed, this gets reversed, and this one gets reversed. But the issue here is that after, when we apply our dict mapping, we're going to pass through and say, okay, one for all maps to Midoriya, that's fine. Explosion maps to Bakugo, that's fine. Okay, one for all maps to Midoriya. Well, we're going to actually overwrite Midoriya here with All Might, and then finally we'll get zero gravity, and that's no big deal. So we end up with only 3 items, as we expected, but there's no list here. So we'll need to take on a different solution. So in addition to using map and reversed, we can actually use a dictionary comprehension. And if you're familiar with list comprehensions, they work pretty similar. So what we'll do is we'll store our resulting inverted dictionary in this variable. And then we'll open up our dictionary comprehension using the dictionary symbol with a brace. And then the first part is actually what we want each pair to look like. And then the rest of it is the loop. So the first part, in this case, is we want values mapped to keys, right? And then we'll say for each key comma value in my dict dot items, and that's it. That's the whole dictionary comprehension. So this is going to run item by item in our dictionary and flip the value with the key. And this works very similar to the way that mapped and reversed did. And then when we look at this dictionary, we'll find that the dictionary looks exactly the same as the previous solution. So this technically works, but it doesn't give us exactly what we want, which is a mapping of powers to all the characters that have that power. So at this point, you're probably wondering, well, what solution actually works? And in this case, what we can do is we can actually use a library that's built into Python called defaultdict. And to do that, we'll have to say from collections, import defaultdict. And then to actually use this default dictionary, we'll go ahead and take our inverted dictionary and assign it a new default dictionary. And the default dictionary takes as input whatever we want the default value to be. So in this case, we want the default to be a list. And what that means is for every item that we add to this dictionary, it's going to automatically set the value to a list. So what that sort of looks like is, let's say we have our inverted dictionary, and we want to know about this key high. And we would normally say, okay, key high equals something. But instead, since every key is automatically a list, we can already start appending to it. So maybe I append 18. And then what our inverted dictionary looks like is that. It's going to look like high and then the value 18 in a list. So we can sort of cheat, do something a little dirty here, and take our inverted dictionary in a list comprehension and say, hey, I want the value to be the key, and I want to append the key. And we'll just keep the key as k. So we'll say for each k comma v in my inverted dictionary, or my dict, sorry, dot items. So we can iterate over it. And you'll notice something kind of disgusting here. You'll notice a list gets populated of nuns, and we'll talk about that. But for right now, all that matters is that the inverted dictionary is exactly what we want it to look like. It's going to have one for all mapped to our 2 characters. It's going to have explosion mapped to our 1 character. And so this is what it'll look like. And you can actually interface with this dictionary as exactly like a normal dictionary. However, while this is all good and it works, it is considered very, very, very bad practice. And I'll say that because at this point, we are using a list comprehension. And if you know anything about list comprehensions, the whole entire point of a list comprehension is so that you can generate a list. In this case, we generated a list of nuns. We generated 4 nuns in a list, and if we had even more comparisons to do, let's say we had like 200 mappings, you would get a list of 200 nuns, and then this list would get thrown away. So instead, what you might want to do is just a standard loop. So you might want to do something like, for each k comma v in my dictionary And actually, let's go ahead and reset our inverted dictionary first. And then we'll say, okay, for each k, comma v in my dict.items, or my dict.items. And then there's no real condition. All we really want to do is say, yeah, let's map that just like we did in our original list comprehension. My inverted dict v dot append k, and that should be it. And then if we take a look at our inverted dictionary, it should look exactly the same. So this would be the preferred solution, just to use a loop. I wouldn't use a list comprehension because you do have that byproduct list. But otherwise, that's the third possible solution. Now, there's one last solution to this problem, which basically is just a straight up for loop, but it allows us to avoid importing default dict for one, and it gives us the solution that we want. And so the way that's going to work is we're going to take our inverted dictionary and set it equal to just an empty dictionary, right? And then we're going to loop over, as we would expect, of our original dictionary. So for each key, comma value in my dict dot items. So what we're going to do actually is use this function called setDefault. And what that allows us to do is say, okay, we want to insert some key with some default value. And in this case, since we're swapping them, our key is actually value, and we want our value to just be an empty list. And then we're going to append to that k. And what you'll find out is that the resulting dictionary is exactly what you wanted, no wrapper. This worked perfectly, 2 lines of code. In my opinion, the preferred solution. Of course, if you know that you have a one-to-one mapping both sides, you don't necessarily need this solution, but this is probably the most versatile, best solution of all of them for sure. At this point, we've covered pretty much all of our solutions. The only problem now is what if we want to reverse the inversion? And typically, you would expect to be able to just re-invert the dictionary. And for a dictionary that looks like this, which would be the bad output from our first 2 solutions, we would be able to just invert this using a regular dictionary comprehension. So we'd say for value colon key for each value, for each key comma value in my partial dictionary dot items, and then that will produce the inversion. So you can actually run this same dictionary comprehension to flip back and forth between the original dictionary and the inverted dictionary. Problem is we actually have lists in our solution, so this isn't going to work. So we'll have to create a more interesting dictionary comprehension that looks something like this. We'll say for each key in my inverted dictionary, and then we'll say for each value in my inverted dictionary at that key. And now you have all of your new mappings. You'll have decu map to one for all might map to one for all. So in this case, you can pretty much just imagine that this is a nested for loop. So for each key in inverted dictionary, and then for each value in an inverted dictionary at that key, and then you're going to iterate over those and make a value key mapping for every single value that you come across for each key. And that'll give us this inversion. At this point, we're pretty much done. We've covered all the solutions, and we even got a little bonus solution on how to invert the inversion. But at this point, I like to do a little bit of a performance check. So we're going to go ahead and copy actually these strings from the performance check on the website. And all we're doing here is copying each of the strings for each of our solutions and loading them into Python here. And then we'll be able to use these strings to run our performance tests. And you can actually see the results of that here below in the article, but what fun is that if I didn't run them for you? So you'll notice in the article that I use time it straight up. Since then, I've liked to use sort of the better solution, the repeat function, which lets you actually run the test a few times so you can sort of get a lower bound on the solution. So I'm going to go ahead and do that instead. And let's go ahead and clear this out of the way. So what we typically do is we would say, okay, minimum of time it dot repeat, and then we would pass the statement that we want to test. So if we scroll up, our first test would be map and reversed, and we would take that, put a comma, and then we would say our setup function would be setup, and then we want to write how many times the function is going to repeat. So in this case, let's just put 10. And then we'll run that. And that's going to run for a little while, and we'll wait to see sort of what the result looks like. Okay, so we have 1.47, and then we'll go ahead and clear out that statement and try a different one. So the next one would be the dictionary comprehension. Okay, and that one runs quite a bit faster in about a third of the time. But remember that there's a bit of a drawback with this solution. And then we'll run the default dict solution. Okay, and then we'll finally run our brute force solution. All right, so what you sort of can see here is that in general, 3 of the solutions run roughly about the same time. Our slowest solution is the default dict solution, and ironically is also the worst solution, right? Because we don't want to use that because it would be considered bad practice. We don't necessarily want to use a dictionary comprehension that has this side effect. Remember, this returns a list of nones, or at least in this case, a dictionary of nones. And we don't want to do that. What we would do instead is pretty much avoid this situation altogether and instead probably go for maybe a mapped in reverse solution or the slightly faster brute force solution. I prefer the brute force solution. It is a lot more convenient, a lot more readable, and you can tell exactly what you're doing in this line. So although if you're against these 2 lines of code, maybe you can opt for something else. But what you will notice that is in general, these dictionary comprehensions are pretty fast if you're not using, an extra library on top. And as a result, this solution, if you have a one-to-one mapping and you're not worried about losing anything in the inversion, this might be the solution for you. It's quite fast, and it's fairly readable. It's just for each value key, loop over the keys and values, and you swap them. So it's pretty good, pretty clean. But other than that, these are your 4 solutions, and take these performance metrics with a grain of salt. That's all I've got for today. So if you like this video, make sure you give it a like, subscribe, all that fun stuff that lets YouTube know that this is a good video, so you can help grow the channel a little bit. Also, I have a Patreon. I'll list the current patrons on the side here. One of the things I would have liked to have done is had some My Hero Academia art in the background like I did in my last video, but I'm a little worried about running into some copyright issues. So if you know anyone or if you draw any art yourself and you would like to contribute it to my videos, please let me know. I love to feature some of that stuff, but again, copyright's an issue, so please let me know. And that's it.